Can't hear me, but I'm going to talk at about this rate, so hopefully you can hear me. But if not, throw those headphones on and you can hear. It's a silent disco. Okay, I am Austin Griffith. What do we have here? This is kind of a weird screen. I guess that'll work. I'm Austin Griffith. I work for the Build Guild DAO. We do education, prototyping, and grant giving. Our education product is Speedrun Ethereum. If you have technical people, technical Web 2 people, if you have nerds coming into the space and they're trying to figure out how to get started and kind of learn the aha moments, tell them to go to Speedrun Ethereum. Speedrun Ethereum is just like this condensed curriculum that will take your technical folks straight through those aha moments that are really important, not just teaching you kind of the how, but also the why. Let's get MetaMask out of there. But after our educational stuff, you'll build a DEX, you'll build state channels, you'll build all of these apps that are really applicable to the space and help you get an idea of like what kinds of things you actually build on Ethereum, not just using it like an expensive database. For instance, building a DEX is really important. It's going to teach you about hyperstructures and LPs and stuff like that. But then once you're done learning, we have this tool called Scaffold ETH, which is made for prototyping and building apps, which I'll show today in a real quick speed run. And we also build a lot of apps with Scaffold ETH. ABI Ninja is a way to it's like an instant front end for any contract. Hacked wallet recovery came from our community. It's like a Flashbots tool that takes a wallet that's been hacked and packages up a Flashbots bundle to sweep any remaining assets that are locked in that account. And then what was the other one here? I think it is Address Vision is another little utility we have that's written in Scaffold ETH that's just a handy public good for the ecosystem. Let me close all those out. And then on the other end, we do a lot of grants. We give a lot of small grants on the edge to small hackathons and builders working for open source. But today, it's all about building apps quickly, and I'm going to dive into Scaffold ETH 2. I've already done this part right here, but let me just show you one more time. What you do is you can fork the repo by going to GitHub and stealing that, or you can run this, whoops, I didn't want to do that. Or you can run this npx create ETH. Either of these commands work. And what's going to happen here is it's going to give you kind of a choose your own adventure here. We'll name our project London or something like that. But this is the important part here. You kind of have this choice between hard hat or foundry. And it lets you choose which one you want to use. Some teams want one, some teams want others. We just want to have the optionality there. I've already chosen hard hat for this project. I've given it a name. I've spun up Scaffold ETH. There's 3 different commands. You'll see it in the repo, but you have to do a yarn start, and that brings up your front end. You have to do a yarn chain, and that brings up your blockchain, and then you do a yarn deploy, and that is going to ship your template contract out to your local network. And this is the most important part of Scaffold ETH right here. So you have your smart contract here, and let's add a public address delegate, right? So this is just not delete. There we go. We're going to create a delegate, right? And if I hit save there and I redeploy this, now over in Scaffold ETH, I have a front end that's auto-adapting to my smart contract live as I'm deploying things. So this lets me really tinker with and understand how I want my smart contract to work. Uh-oh, looks like something didn't work here. What did I do wrong here? Address public, right? I wrote it wrong. Here we go. All right, let's try that again. Please work second try. And what we're going to see is this new delegate shows up, right? Okay, so now we have this new delegate. I probably should just show you the smart contract real quick just so you have a lay of the land. We kind of put in a handful of things in this template smart contract just to give you an idea of primitives and data types, just to kind of get you started with Solidity quickly. If you already know Solidity, you're going to be able to just jump in here and start hacking. But if you don't, you can go to Solidity by example and use the examples from Solidity by example and copy them in here and tinker with them. But let's see, we have a classic greeting contract here. A really interesting thing, it looks like it's a payable function, and if the value is greater than 0, we set some premium flag. Let's go do that real quick just to do a hello world. And I'll grab some money from the faucet. and I'll hit send, and we see our greeting change there, right? But what we want to do is, let's pay a little money too. I'm going to pay 0.01 ETH, and notice this is kind of clunky, you might think. This is like a UX, DX kind of thing. We want the developer to have to know what's happening here. I can't put in 0.01 because we don't have floating point math. It's in the EVM. So what you have to do is hit this little button, and you have to take it from ETH to Wei. And of course, you would not want your end user to do that. But here, while you're tinkering as a developer, you absolutely need to do that. So you have it in your mind what's going on and what is Wei and what is ETH. And there we go. We just paid a little money. Our little premium flag went to true. We're able to set the greeting to hello world. So that's basically it. It's just a greeter contract. So let's say this is your hackathon project. It's time for you to build something cool, right? So you can get in here and add things to your smart contract, right? I'm going to start with adding a delegate, and then I'm going to create a function that lets me, update the delegate. Let's see, what are we doing here? There we go, set delegate, yep. Looks good. I'm just going to let anybody do it too, so it's like it's like totally public function that anybody can set, and it's kind of just this arbitrary delegate. I don't know exactly what I'm doing here. Maybe I would have the delegate receive money as people are setting the greeting, but I don't have time for that. We have 14 more minutes left, so I gotta just kind of ship something small so it makes sense. So we have this new delegate address that we added to our smart contract, and then we added a set delegate function. And if I go ahead and deploy that, let's see if we can tinker with it in the front end. There we go. And now we have this new set delegate function here, right? And if we want to set Vitalik to the delegate, look at that. It does this nice ENS avatar preview. You have a nice blocky preview. It just looks nice. And if we hit send here, what happens? There we go. Now we've set Vitalik as our delegate. Now let's pretend this contract is solid and it's what we want. Obviously, you've got all weekend. You would spend a lot more time getting your smart contract the way you want. But since this is just kind of a compressed demo, let's just pretend I just spent a couple hours working on my contract and I've tested it and it all looks good. And now it's time to ship our app. So this is you kind of shift modes. You kind of go from tinkering here, where you're making changes to your smart contract and you're tinkering with it and testing your assumptions in the front end, to let's build a front end that our users could use, right? So I just want to bring in this delegate and this set delegate functionality into just the React app and show you guys hooks and how quick it is to build apps with Scaffold ETH. So let's go into so we were in the hard hat mostly there. Now we're going to go into the Next.js. And we're going to go into the app, and we're going to write some stinking React. And you'll find, if you're building a hackathon project or anything that people use, you'll spend about this much time writing your smart contract and about this much time doing stupid React. But that's the game. That's the name of the game. If you want to build consumer apps and things that people use, you got to spend a lot of time on that UX. Okay. So let's see, our landing page kind of lets us know who's connected. It gives us some guides. I'm probably just going to tear most of that out. Let's see, let's just delete some stuff here. Whoa, maybe to there. Let's see, no, one more. How's that look? Did I clean it up? There we go, nice. Okay, so what I want to do now is I want to display the delegate. So we need to do a read from the contract to display it here. So when you go to do a read, you're going to use a hook. And by the way, let's look at this hook right here. This use account hook is from WAGME. So if you end up needing more documentation there, you can always go to wagme.sh and learn more about their hooks. But we've even wrapped their hooks into something even more abstract, because we deal with the wallets and the network and stuff for you. So really, you can use our hooks, and I'll get to that in a second. Let's do that. Let's get in here. So this is the WAGME hook, and it's given us the connected address, and that's how we're displaying this here. And notice this nice address component. Again, just like in the input, we have these really nice components that are going to do things like ENS out of the box to help you build your app quicker. Okay, so let's make a hook that is going to use scaffold contract read. That's what I want. There we go. It's kind of a mouthful, but it's a really powerful and nice function. What I'll do here is I'll put in a contract name. And look at that, it auto-completes with my contract. So if I have a bunch of contracts, they're going to auto-complete in there, right? We want your contract, and then function name, And what are we going to call? Hopefully it does. Look at that. It does some nice completion here. What do we want? Delegate, owner, greeting. I think I want the delegate, right? Okay, and no arguments will go in. And what's going to come back out here is going to be some data that we can rename to delegate. Wow, it's a good thing I didn't try to do a prediction market. I'm not going to have enough time. I'm barely going to get this thing deployed. I was thinking about doing a little prediction market, but then we reverted to just doing this delegate. Okay, and then let's grab this address component, paste this in here, and we'll say the delegate address is this dude's address right here. And let's see if it worked. Yeah, it's Vitalik. Okay, so we're displaying the person who's connected. We're displaying the delegate address from the contract, so we're reading a value from the contract. Now I want to demonstrate writing to the contract, right? So what we're going to need is probably some input form that will probably track in the state, and then we'll do some use contract write. So maybe, let's see, let's just start working on this UI and see if it kind of unfurls for us here. So we want to, what, like set delegate. Okay, and then we're going to have an address input component. Yeah. And let's see. Let's call this new delegate. And then on change, we'll do something like set new delegate. Okay. Oh, I want that to be new delegate. Oh, new address. I think that works. And then let's see if it like recognizes that I need some state here. Yes, it did. All right, cool. And I need to import use state. Oh, where are we at now? Something still, oh, I need to close the address input. There we go. So I think, oh, is it still broken? Yeah, nice. So now we have this input form, and if I put in atg.eth, it should, oh no, it's not. Let's see, it's not tracking the value somehow. Oh, this needs to be value, I think. There we go, there we go. Okay, so then if I do atg.eth, okay, and now we need a button. So we're tracking that state now. We have this nice input component that lets us put in an address, and then it resolves it and everything. But now what we need is a little button we can hit right here that says set delegate and does a write on the contract. And so that will use, we're going to do const use scaffold contract write this time. We're going to write to the contract, and it's going to be shaped the same. It's going to have this object with this contract name, right? And we also need some function name of what do we want to call? We want to call set delegate, right? And then for the args, we're actually going to have args here. It will be new delegate, right? How's that looking? Okay, and then what do we have? Like a write async that comes back here? Yes. And I'm going to rename that to set delegate. So with this hook right here, we're reading the delegate from the contract. And with this hook right here, we're going to write a new delegate to the contract. So you're reading and writing from your contract from these nice hooks right in your front end. Let's go wire up that button and see if we can get this thing to work. Let's see, div, I don't even know what I'm doing. Button, definitely. Oh, give me a class name. Oh, come on. Class name equals btn dash primary. Oh, there it is, almost. The AI is making me think for myself. I hate it. All right, and we'll do slash button. There we go. All right, and is it set delegate? Yes, we call set delegate, right? It wired it up correctly, so it should call this function. All right, let's go find out if it works. And then if we have 6 minutes, we'll ship it live. Oh, wow, that's really ugly, but we don't have time to make that look pretty. So what I want to do is make sure I can do atg.eth and then hit set delegate, and then what we're looking for is this delegate address. Yes, okay, it works. All right, so we've tinkered with our smart contract for a couple hours and we got it right. Maybe we wrote some tests. Then we tinkered with our front end. There was kind of this moment where we're tinkering with our smart contract and poking at it. And that iteration is really going to help you get your contract figured out. Then we moved over to the front end and we kind of built out an app that's more like user facing. Now it's time to deploy this thing live, right? So if we want to go live, we're going to need to put both a smart contract up and then an app on whatever network we go to. And we are running out of time. So let's hope, let's see. So when it's local, you're on your own local blockchain. So it's free basically to deploy, right? But if we want to deploy to like Base or Optimism or mainnet, we're going to have to pay. So to do that, you create a new account. You do a yarn generate. And this creates a local account that's already get ignored, that's isolated to just your deployer, so you only send it just enough money to deploy. You already have this private key hidden, so you can't leak it. So what we're going to do is, I'm going to get this account and I'm going to send it some Base, and we will deploy. And I'm going to use Punk Wallet, which is just like a quick web wallet that was written with the original version of Scaffold ETH. Thankfully, we have Scaffold ETH 2 now, and we have the builders in the audience, and it's a much cleaner, much nicer tool. Let's go Base. Oh man, I don't have very much Base. I don't need very much Base. That's a good point. Let's see, how much? Oh yeah, $20 is going to be enough, right? Boy, I hope so. Okay. 5 cents to deploy a whole contract? Yeah? All right. All right, let's go. The blobs. Yeah, I love them. All right. So now, just like we were doing that yarn deploy, I'm going to do a yarn deploy, but I'm going to add -- network Base and cross my fingers that all this works. The live demo gods. And what this hopefully does is take that smart contract we've been tinkering and deploy it to Base live, which I think it did, right? It deployed right here. Should we go to Base Scan and see how much that cost real quick, just for the blob check? That was 2 cents to deploy that smart contract. Ooh-wee! We are entering a new time where mass adoption and cool kids from California are building apps on Base. Boy, something new is about to set off. Okay, so our contract is out, but our app isn't out yet, and we have 3 minutes left, so I better get cooking here. What we need to do is, first I need to switch my front end over to, notice it still says hard hat. This is another really nice thing about Scaffold ETH, is there's a scaffold config, and with one button, I always switch that over. With one button, you can switch your whole app over to a different chain. So watch this. If I change this to Base and hit save, our app automatically now is on Base. And oh man, I don't think I want MetaMask. I'm gonna go back to burner wallets. False save. You don't usually use burner wallets in production, but I'm going to. Okay, so now our app, just by putting it on Base, our app is on Base now. So look what happens when I click on this address. Remember all those address components and all those things? When I click on that address, it's going to take me to Base Scan now. So if I wanted to go to Optimism, I'm going to change one variable there and deploy my app, and my app's on Optimism and it's ready to go, right? So a lot of these things are going to be handled for you. Also, if I come in with my MetaMask and I'm on the wrong network, it's going to bump people over to the right network. I don't know if most wallet providers do that. Do they do that out of the box now? Yeah, like Web3 modal, do they switch? Okay. All right, so here we go. We got to do one last thing. Our contract is live. I don't think my app is going to get deployed in time, but what I do is yarn Vercel YOLO prod. And what that's going to do is put my app out on Vercel. Yes, no, London. It's never going to finish in time. There's no way that's going to finish in 1 minute. But we might have to just pretend a little bit. So we were able to iterate on our smart contract using this nice adaptive front end. Then we were able to write a nice little UI that's kind of ugly, but you can spend a little bit more time on it this weekend. And then we were able to deploy that app live to Base and then deploy the front end. Oh, yes. No. I don't want to modify the settings. Just work. Okay. So this is going to take a couple minutes to deploy, and I think I'm going to have to be out of here. But this should help you quickly build your hackathon projects. It's going to have the stuff that you need out of the box. It's a very clean build. Carlos doesn't let anything get merged into this thing that doesn't belong. So know that this is a very forkable, very quick and light and lean tool, but also very powerful. You can build production apps. Okay, thank you all very much. Go check out Scaffold ETH. Go speed run Ethereum.
Coming to my talk on Uniswap V4. Today we're going to be talking about dynamic fees. And I guess, show of hands, how many people have heard of V4 and hooks? All right, how many people have built on hooks or like written Solidity for hooks? Okay, so a handful of you guys. Cool. So I'm Sauce, or Sauce Point. I do developer relations at the foundation. I know a lot about V4, so if you have any like V4 questions, that's me. And so today we're going to go into dynamic fees and like how to do dynamic fees with hooks. And before we start, we're just going to like quickly kind of touch on like one of the biggest changes in V4. And so in V3 there was originally 3 fixed tiers, 5 bips, 30 bips, and 1%. Governance voted to add 1. So we have 4, and those are sort of just the fees that you are sort of restricted to. Like LPs have to pick one of these. In V4, this is now fully continuous, so you could have like 4.9 bips, you could have 10 bips, but V4 also adds dynamic fees, which is super flexible and super interesting. These can be changed at sort of on any sort of spectrum, so like you could change it once a year, you could change it for the block, you could even do it at the transaction level, so for every swapper, they could have possibly a different sort of fee that they pay. And this logic is defined by the hook itself. So it's like really any sort of arbitrary solidity. You could, in theory, like look at the Chainlink oracle, and dependent on if the price is above or below the Uniswap price, you could set your fee based on that. So it's super flexible, and like the hook has full control over how the fee is set. But before we go into that, like we'll just do a quick refresher on like how hooks work and what hooks look like. So whenever I say hook, it's kind of overloaded at this point. It's a contract, but it's also a function, and then it's also like a feature as well. So a hook is, so this is an example of like a hook contract. It's super bare bones. You sort of adhere to a certain function interface. And so in this example, we have like before swap. And so the logic inside that function will execute before a swap happens. In this case, we're just incrementing a number. It's pretty standard. This is kind of what hooks look like greater picture, where at the start of the swap, we check if there's a before swap. If so, we'll run it. Then we'll do the V3 sort of concentrated liquidity math. And then you can also do after swap as well. And you're not just restricted to the swap hook functions. You could also do liquidity, like before and after liquidity gets modified, before and after a pool gets created. Just because you use before swap doesn't mean you're restricted to before swap only. You could use all 10 hooks that we have. Here's another picture of what hooks look like. So user does a swap, touches the swap router then connects to the singleton pool manager, calling swap, and in this example we have an after swap function. I would like to highlight that hooks, like the better hooks, essentially service like all sorts of different trading pairs. It's not restricted to one trading pair. So in this example, you can see that like ETH/USDC and UNI/USDC work with this hook. There might be cases where like your hook should be specific to like stable pairs, but in general, one hook contract should service multiple trading pairs. That's something worth calling out. So now, dynamic fees. We're just going to go through like a super easy example, just so you guys are kind of familiar with like how it looks. And so if the block number is even, we're going to set it to 69 bips. If the block number is odd, it'll be cheaper. I don't know why you would do this in production, but I don't know. Could be cool. So this is what it looks like. So we have our hook contract, our hook function. In the function set dynamic fee, this isn't like a standard interface. You can kind of name it whatever. You could provide whatever parameters you want. The only important thing that you really want to be aware of is you essentially tell the pool manager saying like, hey, for this trading pair, for this key, this is the value. This is the swap value. And then the pool manager will cache that value, and then whenever you're running swap logic, it'll reference the swap amount. And so if you wanted to do it on every single swap, you would just call this function before swap. So before every single swap happens, we'll just update the fee. In this example, there's actually this cool optimization where you could do, because the fee is really only set at the block level. And so you really only need to set the fee at the top of the block swap. So for this first swap that happens, you set the fee. And then for all remaining swaps within that block, there's no reason to update the value because you'd be updating it for the same thing. So that's a little small optimization that you could do. But again, you could do it every transaction. You could do it top of block. You could do it whenever you want. Like maybe you manually just call set dynamic fee from your wallet. And then to showcase another hook, right after initialize, you can set the fee there, because whenever you initialize a pool with a dynamic fee, its fee is actually set to 0. So if you're not updating it before every swap, you'll want to set it at some point, setting an initial value. So you could use the after initialize hook function. So pool gets created, a bunch of storage changes happen. It'll call into your contract in the after initialize, and then that's when you tell the pool manager that the fee is whatever value. And so this is so there's a lot of back and forth with setting fees, and this is what it looks like. So user, touches the swap router then calls the pool manager.swap. Inside the pool manager, it looks to see if we have a before swap function, and then in our case we do, so then it'll call out to our contract, and then our contract will say like, hey, the fee is changed, the fee is equal to whatever value you set it to, and then it returns back to the pool manager to run that actual concentrated liquidity math using the new dynamic fee. And really that's all there is to it for dynamic fees. They're super simple, but also hyper flexible. And I think I wanted to cover testing here, because right now V4 doesn't really have an interface, and testing should be on testnets locally or with Foundry unit tests. So I'll just kind of quickly touch on it. And if you are thinking on building for the hackathon, I highly recommend using V4 template. I have a link at the end, but essentially it does all this really nice code setup for you, where we deploy the pool manager, we deploy all the test routers, we create test tokens for you with all the approvals that you need. There's an example on how to deploy a hook within Foundry unit tests, because hooks encode how they, like which functions they use inside their address. Like the first few characters of an address signal which functions you're using, and so there's this nice little like mining tool that you can use within v4 template to deploy your hook locally. Also, things that we do in setup is we initialize the pool. In this case, you can see that whenever you create the pool, you need to have a special like fee value to signal that it's a dynamic fee. And so there's a special flag for that, and we create that pool for you. We also seed some liquidity initially so that you can kind of just jump right into it and like write tests for your hooks or for your dynamic fees. In this example, we're sort of setting the block number to something even. We're running a test swap, and then we're confirming based on the output the number of tokens that we get if the fee was correctly charged. So on the even blocks, we see that 69 bips was charged, and then for good test coverage, on the odd blocks, we see that 5 bips was charged. So that's a little note on sort of hook testing and verification, and definitely recommend using Foundry, because if you do it on testnet, sometimes you get a reverted transaction that isn't very clear on like what went wrong. So the unit tests are a lot better for stack traces and stuff. And so now, yeah, for different ideas that I have around dynamic fees, because I have been saying that they're like super hyper flexible. So you could do things like volume-based fees to incentivize like swap activity. So if like swap activity is down, like maybe the fee should be lowered. You could sort of try to mitigate MEV or like front runners, which always prefer being like earlier in the block. And so you could do something where at the top of the block the fee is a lot higher, and then like later on in the block, or as more transactions happen, you could sort of decrease the fees that way. You could do sort of directional taxes for like meme coins and shit coins, where if you're dumping your shit coin, you charge a higher fee to sort of disincentivize that. You could do fee discounts for liquidity providers, for high volume traders, because like I said, you could do fees at the transaction level and at every single swap level. I don't know if you guys are familiar with AMM. It's the new sort of auction AMM design from Dan Robinson and Austin Adams, where essentially they auction off the rights for somebody to set the dynamic fee. Like you as a bidder will bid to be able to set that dynamic fee. And so some sort of variant of that sort of applies here. And then lastly, the VR GDAs from T11s, where you kind of have like this like decaying auction that can also increase in price as well, dependent on like demand and volume. So those are some cool ideas related to dynamic fees. And then quickly on prizes that we're offering at the foundation this weekend. So we're offering 3 prizes for what I call first-class hook features. These are things that are supported like really well and like natively within v4 hooks. So dynamic fees is an example. You can do custom curves in v4. It's a little bit messy right now because there's a pending change, and I only recommend it for the brave. But it is possible, and if you are interested in custom curves, come talk to me. You could do no-op. You could have hooks charge their own fees or do sort of different like value redistribution using hook fees. And then in the other category, we have hooks and external integrations, where you can combine a hook with like maybe a ZK coprocessor, or combining v4 hooks with WorldCoin to sort of change the dynamics of swappers and LPs. And so we're offering prizes for that. And then the last track is just kind of like this open track, where if you're not developing a hook directly, but you're integrating or doing something tangential to v4, that will apply to you. So anything on like MEV, lever, just in time. On the public goods stuff, there's like Oracle hooks that are cool. Liquidity staking or like liquidity incentives on v4 haven't been built yet. And then lastly, we have like pool operators, which are like periphery contracts / like swap routers. Like you could like maybe design a contract that does atomic arbitrage, and a portion of the proceeds get donated to liquidity providers or something like that. And yeah, so those are the 3 tracks and the 3 prizes. Here are the resources. So all that dynamic fee example exists under my repo, SaucePoint on GitHub. The template is under the Uniswap Foundation. Highly recommend using that. And then we have V4 by example, which is, I don't know if you guys seen it, but it's a fork of Solidity by example, where we have a bunch of nice little snippets and different sort of Solidity snippets related to V4. There's information on swap fees. If you're lost on like how do you create liquidity, there's examples and Solidity snippets for you to work through. Oops. I don't think this is reloading, but yeah, that's all I had. I am SaucePoint on Twitter and on Telegram, so feel free to reach out to me, and then I'll open up the floor for any questions if anybody had any questions. Yeah, message.sender. There used to be a really good way, but then Labs ripped it out. Conveniently, it's here on V4 by example. So within hook functions, there's you have an option to provide like arbitrary call data. And so this arbitrary call.
That isn't secure, though. Would that not be secure, though? Because like then the user could just pass in some arbitrary value and then.
Yeah. There's like, I mean, I guess you could write a periphery contract that like guarantees that the message sender gets passed to the hook. But yeah, this is currently really the only way to access like the wallet's address at the moment.
So the lock, there's like some sort of function that's like .lock.
Yeah, you can't call .lock from wallets anymore.
Okay,
You used to be able to, and then that information would get provided to the hook. But
Okay, thanks.
I think they took it out for like gas reasons. Well, cool. If there are no other questions, I think we're just about on time. All right, great. Thanks, guys.
Yeah, let's get started. Nice to see you all. I'm Dan. I'm an engineer on the team at Hyperlane. Who here knows about Hyperlane already? That's amazing. So you may have heard about Hyperlane in the context of a protocol. Today I want to talk about it in the context of it being an interoperability framework and what you can build on top of it, but also for it, because it spans many VMs and chains, and it's a very kind of like wide encompassing protocol. To set some context, nowadays dApps live on increasingly divergent infrastructure layers or like settlement layers. Sure, you've heard about like monoliths. If you have your dApp live on Ethereum, maybe there's one trade-off space that you're looking to make. Maybe you want access to lots of liquidity and a lot of protocol composability at the cost of high fees. And Solidity. If you want to deploy on Solana, you're going to have lower fees, but you have to learn a new paradigm with managing account state and learning Rust. Some opt for going the app chain route, like Cosmos and Polkadot. Those who want to have control over block production, maybe they want to tweak consensus parameters or transaction inclusion priority. But that still requires you to learn a new, smart contract paradigm. If you want to stay within the Ethereum realm in the EVM and use Solidity, you might build your dApp as a rollup. And you're going to have to do with DA layers and whatnot. But obviously, going on the layer 2, you lose some composability that's inherent on the layer 1. But you do give users lower fees. And then there's even been talk recently about ephemeral chains, those spin up based on demand, just like in Web 2 with cloud computing services and even L3s. But with that, interoperability today is highly fragmented. Say if you're building a rollup, as a developer with your dApp, you have to support several interfaces like deposits and withdrawals from L1 and to L2. Asset bridging, like you have to integrate another provider, most likely, to bridge tokens to other L2s. And that doesn't even touch on general message passing. Like if you have a dApp that lives on several chains and you have a cross-chain DAO and you want to propagate the DAO decisions from one chain to all of your deployments, that falls under general message passing. And I don't think there's too many providers that help with that off the shelf. We've had Aave integrate with us, but with a custom integration. But we're trying to service all of those use cases on as many VMs as possible in chains. If we keep to the rollup world and you look at Caldera, you can go onto their website, and within 5 minutes, it's really just mix and match for a variety of parameters, and you can launch a rollup. You can use the OP stack, pick the native token and the DA layer, and then you have a rollup, and it's up and running. It's probably scalable. It's up to you to, how you, take it further, and if you want to decentralize the sequencer and so on. But you're still kind of secluded. You don't have easy access to liquidity other than via the layer 1. And you have to start playing the BD game. You go to other, bridging providers or L2s, and you set up a roadmap to plan a bridge deployment. And we think this could be different. We view, for instance, if you look at this modular stack, I think interoperability should be part of it intrinsically. Maybe when you deploy a rollup, you'd also have a bridge deployed by default onto, for all the chains you want to connect to. And this was the original Hyperlane vision, which all of you might already be familiar with. And we're trying to make it clear that Hyperlane is way more than that. Hyperlane really what it does is it separates the transport layer of interoperability from the application layer. So if you think about the layers of the internet OSI stack, You know, you have like 4 broad layers, and say your dApp lives at the application layer. Ideally, you don't want to have to think about the bridging provider you're using or the security they're using. Maybe you want to have it configurable, but not have to deal with all that complexity yourself. So all you have to do is integrate with the Hyperlane smart contracts, and then that abstracts away. Again, if you're talking to an EVM, like to your rollup, and you talk to the layer 2, maybe use the canonical bridge. If you're talking to a Cosmos chain, maybe it's a multi-sig, but that's all abstracted away from you at the dApp layer. And then, yeah, below the transport layer, there's a bunch of off-chain infra where there's a relayer that's running. There's a key funder that makes sure the relayer has funds so it can keep sending messages cross-chain, and a bunch of other stuff. And obviously, at the lowest level, we're kind of just abstracting away the internet. So we're really trying to provide a consistent interface. You integrate with Hyperlane once, and then your protocol is future-proof to any sort of like bridging models that become available. At a bit of a lower level, say you're on an origin chain, want to send it to a destination. What you do is you call a contract we call the mailbox. You tell it the destination chain, the recipient, and the body can be anything, like a bunch of bytes. It could be an encoding of your choice or whatever. Then there's a relayer that indexes that mailbox, and we'll see, hey, there's a new message going in a certain direction. By the way, the relayer is permissionless. And it will call the destination chain, the mailbox contract on it. And very interestingly, the mailbox will call into the recipient contract, which gets to pick the security module it wants to use to validate like the authenticity and security of the message. So say, again, you're on a Cosmos chain maybe, and your message is incoming from a Cosmos chain. You can use IBC for that and tell the mailbox, just use the IBC security module. You're on an L2 and the message is coming from the L1. The recipient can just say, hey, just use the canonical bridge. And this is kind of the same thing, but visualized more broadly, like across ecosystems. If you're launching something on Cosmos, and IBC is amazing, but you don't want to, be constrained to that, and there's lots of liquidity and users available outside of that. Same with the layer 2. It took you 5 minutes to launch something on Caldera, but you don't want to be isolated. You can pick different security modules. Obviously, this isn't ideal from a security perspective, but we try to take a very pragmatic view where you can launch something from day one, and you don't have to wait for like 2 years to wait for a light client to be developed between, the rollup, the VM that your rollup runs, and then the broader crypto ecosystem. But obviously, making it very easy to select different security modules wouldn't make much sense if you then need to come to us, like Hyperlane, and lobby us to deploy onto your chain. And so to that end, we've invested a lot of time and resources into being fully open source and having great docs to help you deploy Hyperlane and run the infrastructure on your own, should you want to. There's a link to our docs website in there. And I'm actually going to run you through deploying a Hyperlane general message bridge, but also a token bridge, without actually running commands, because workshop internet tends to be terrible. But what you have to do is basically go to npm and install the Hyperlane CLI. If you've just launched a new chain, you do config create chain, which just asks you for the RPC URL, a name, basically stuff you'd add onto your MetaMask wallet when supporting a new chain. You can specify the ISM, like the security module you want to use, and say if it's a multi-sig, it's going to ask you for the list of signers and the threshold. And then that's all. You're going to have some output JSON files that you're going to be able to use, like with the configurations you just created, and run this deploy command, which is like target chains, the files you just created, and a signer key. And it's going to deploy all the contracts to all the chains you specified. And I'm going to have basically a production ready, or like at least the private key is going to own it for a start. But it's going to, it's going to be a bridge that you can start working with, further decentralized maybe later, ready to go. But now you need like infrastructure to connect those various chains, right? Again, using the artifacts from the earlier commands, you can run Hyperlane deploy Kurtosis agents, and Kurtosis is this cloud infrastructure company that we've partnered with. it will take your JSON artifacts and output a URL. You click on it, you just input a private key to run the relayer and validator with, and you're going to have infrastructure spun up for you just like that, so you don't need to worry about it, and you can start working on your cross-chain dApp, having like the entire bridging layer abstracted away from you. And you can even send a test message with the Hyperlane CLI. Cool, so now you have like general message passing live. Maybe you want to start bridging tokens. And warp routes is our take on token bridging. It's again a collection of contracts that allows you to move like either native tokens, ERC20, ERC721, to foreign chains, and it's basically an abstraction on top of the mailbox contract that I mentioned earlier. And we provide the UI template as well. Takes another 10 minutes to deploy Token Bridge. Again, you run a command to configure the warp route, you deploy the contracts, you clone the warp UI template, pasting the configuration from your earlier deployment so it knows how to connect to the chain and all of that, and just yarn dev to spin up a local UI, and you have a live token bridge with a nice UI, again, ready to go, and to show to your investors and maybe convince them that maybe it's time for them to fund you to build a light client because your kind of app works at the proof of concept level. And since we're at the hackathon, let's also quickly cover the bounties. So you can build at any layer. We tried to keep the bounties as general as possible. So you can build a dApp on top of an existing Hyperlane deployment. You can build a contract like an ISM or tooling for deploying and versioning contracts cross-chain. You can improve off-chain agents like maybe creating a better key funder or tooling for it, or analytics just to track how messages move across chain. One of the bounties is called best permissionless use, and that would involve deploying Hyperlane yourself. An idea is to create a DEX on mainnet that allows you to buy testnet tokens, because some of them are pretty darn hard to get a handle of. So you can deploy a warp route, testnet to mainnet, deploy like either a Uniswap V2 or a fixed price contract for redemption, and then buy, say, from Sepolia to Base, and buy on Base some ETH Sepolia, and then you're able to bridge it back, and you have a bunch of Sepolia ETH. I know the hackathon is very generous and gives you like 1,000 of that, but you get the point. You can also build like a cross-chain key funder, where you have balance on a single chain, but you have like deployments on several chains. And you want to be abstracted away from having to fund all of that because it's an operational nightmare. You can bridge via Hyperlane, then swap on whatever DEX you want. That's available on that VM. Yeah, obviously in the EVM you have Uniswap, but maybe on Solana you have to use Jupiter or something. And you swap there, and then maybe switch to the native gas token of that VM, and there you go. It's all automated, and you just run a service, and it will do the topping up for you. And we also have something called the most creative use of Hyperlane, where we really just want you to, I guess, go crazy. Like, this protocol really spans a lot of layers of complexity and a lot of VMs and a lot of chains. Like, there's many things you could do with it. One of them being like you can register a cross-chain limit order on a Uniswap v4 hook, which you've just seen the workshop of earlier. And you can customize the Hyperlane relayer to scan for prices cross-chain, to find the price limits, and then fulfill it. And then we also have a bounty that's the most generous bounty. It's $4,000 on top of an existing category for the best project, because some of these projects are kind of like big undertakings. So again, you can build anything you want, but should you want more inspiration, scan this QR code and it will take you to a list of our GitHub issues that have a bounty label. Again, some of them are like quite involved, but maybe you can find something that you find interesting. And with that, I'm inviting you to build the modular expansion, and I'll take some questions. If there's no questions, I can keep talking. Okay, I'll tell you a bit about like some other abstractions. Please raise your hand if you have questions. We have some abstractions on top of the contracts we already provide. One of them, they're kind of inspired by IBC. One of them is called the Interchain Accounts API that allows your contract that you own to have control over an address on foreign chains. And the way it works is via an API contract that's deployed, and again, it lives on top of the mailbox. And it can hold funds, and you can basically use this Interchain Accounts API for the DAO example that I just gave earlier, where you want to run voting somewhere on some chain and then propagate governance changes, or yeah, who knows what other use cases. And then there's another API we support. I think both of these are available via the CLI, by the way, like you can deploy them on top of the general message passing bridge. And the Interchain Queries API is basically a round-trip call to read some data from a destination chain at like some contract interface that you probably already know. And once that data is read, the API contract will itself make a call to the Hyperlane mailbox that's like bound back to you, and it will call your contract back with the result of that call. So this is essentially, an asynchronous interface, similar to like how we use the internet today, to read data cross-chain, and probably in the future do write operations cross-chain as well. And Solidity today is built to support only synchronous code, but I think in the future we might be seeing async await hit the Solidity world as well, and start using more and more kind of like Web 2 paradigms we're used to. Yeah?
So a question in that context. So for example, let's say you want to build a very universal oracle with prices from many, many, many dexes, and so you want to grab those prices. You're nodding. It sounds like that would be a good use of that.
Yeah, definitely. Like you can use the Interchain Queries API. Obviously, like you'd probably have to lobby Chainlink to deploy to your chain if it's like a new rollup or something. But if you use the Interchain Query API, you can like bring that data to your chain on demand whenever you need it. So that'd be a great use case actually. And yeah, we've had an event with Flare yesterday, and they're basically a layer 1 that's dedicated to, Oracle data. You could use that as well. Cool. Yeah.
When we need to pay the fees, need to be in the origin. We can connect a paymaster on the front. What's the recommendation there?
You mean for paying fees to send a message cross-chain?
Yes.
Mm-hmm. So I said earlier that relaying messages is permissionless. For the bridges that Hyperlane supports, say off the shelf, there's a default relayer that's configured, and you'll have to pay based on a gas oracle. But if you wanna relay a message yourself, you could do that for free, right? I mean, you pay the gas out of your own wallet. But normally, yeah, the relayer or whoever registers to run as a relayer, they would have to maintain a gas oracle for all the destination chains they support. But you get to pick your relayer actually when you call into the mailbox. So it could be any service provider yourself. Yeah? Very quick.
When you're sending tokens cross-chain, if the token and the contract address is different on each chain, how would that work? Would Hyperlane store some sort of mapping from on the source chain and the destination say, okay, this user is sending USDC on this chain?
Yes.
A different address, so therefore we need to mint new tokens on this chain.
Yeah, exactly. So there's the warp route contracts basically have counterparts, one that lives on the origin chain and one on the destination, and they're kind of aware of each other. We can talk more outside if you want. That's cool. Thanks for attending, everyone. Happy building.
Hello everyone, how are you? Good to see familiar faces from before. Thank you for attending. My name is Germán. I'm Developer Relations at SAFE. And today I would like to share with you what we are building regarding the ERC 4337, how we are integrating it with SAFE, thanks to the SAFE 4337 module. So first of all, I would like to ask if you have heard of it before, please raise your hand. Okay, very good. And I guess in the last couple of months, even year, we've heard a lot of new terms regarding the ERC 4337, right? And now it's our turn at SAFE to integrate it, or to have support for it. In this workshop, I will talk a little bit about the benefits of the ERC 4337, but I see that most of you are familiar with it. Then I will cover how the SAFE Smart Account structure or architecture allows this. I will show what the SAFE 4337 module is and how it is connected with the different actors and the 4337 stack. And finally, at the end, we will see a demo executing a user operation, getting it sponsored with the permissionless JS library and the Pimlico infrastructure. So let's start with the or some of the benefits of the ERC 4337, and apart from the ones that are inherent in for the smart accounts, we have, for example, flexibility of payments, where users can decide how to pay for the gas fees. They can pay in ERC20 tokens, they can pay in the native token, they can even get their transactions sponsored by a third party. There's also freedom of authentication, because it enables different ways of authentication, like multi-signature or passkeys, or maybe quantum-proof mechanism. And also it provides decentralization, avoiding the lock-in of a single relayer technology by supporting different accounts and different providers. So let's see how the SAFE Smart Account architecture looks like. It all starts with the core contract, the account itself, the SAFE. And you may know SAFE, it's a modular smart account. This means that it supports, among others, modules and fallback handlers. There are some more that we will not cover in this workshop, but here, for example, modules allow to extend the functionality of the SAFE by implementing some logic in this module, and modules have access to execute transactions in the SAFE. They can be used, for example, to implement recovery mechanisms, different ways of authentication, and very soon we will see how they will help as well integrating the 4337. Also, we have the fallback handler. The fallback handler is a contract that can be enabled in the SAFE, and whenever a call is received in the SAFE account, if there's not a function implemented that is called in the contract, it will fall back to this contract, the fallback handler, and see if it is implemented there. And if it is, it will execute it there. This is very helpful when we want to integrate standards that are or support the standards that come out in the community, and they are not implemented in the main account, but they require the implementation of new functions, like this case. Regarding the SAFE 4337 module, we need to enable it as a module and also as a fallback handler. The module will allow this module to execute SAFE transactions, and the fallback handler will allow to receive some calls that are sent to the smart account. But just to clarify the difference between these two slides, it is just one module that is enabled with two different roles. So let's see now how the SAFE4337 module works together with the account and also the other actors. So here we can see, first of all, this is the validation step. Later we will see the execution step. But we can see the different actors in the 4337 ecosystem. We have the bundler, the entry point, an account, in this case the Safe Smart account, and then we have a target depending on the user operation and the transaction that is executed. So it all starts with bundlers submitting user operations to the entry point. Then the entry point will iterate on all of them and first validate them and secondly execute them. So first of all, let's say we have just one user operation. It will be sent to the account. Here the safe proxy, your personal account, will receive a call of a function that is validate user operation. If you remember, Safe is not implemented or giving support natively of this CRC, but using the module. So we have the Safe 4337 module implemented as a fallback handler that will be able to handle this call. So the Safe proxy will forward the user operation validation to the module. And now the module will do two things. First of all, check that the user operation hash was correctly signed by the owner of the account. And secondly, and if needed, it will trigger a payment because it is also a module and it has the ability or the grant to execute safe transactions to perform the fee payment to the entry point. After successful validation, the entry point will now call the account to execute the user operation, so calling the execute user op. Again, this method is not implemented natively in the Safe, so the Safe proxy will forward the validation to the Safe 4337 module. And now the module will call the Safe to execute this using the exec transaction from module. And finally, the Safe will actually execute this transaction, whatever it does. So some resources that can be helpful for you, just sharing 4 repos. The first one is the Safe Smart account, where you can find the contracts of Safe. All of them are in the ETHGlobal organization. The second one is Safe modules, where you can find the implementation of the Safe 4337 module and some examples using it. There is the Safe deployments, where you can find where what are the addresses where Safe is deployed depending on the networks. And the last one, the Safe modules deployment, you can see where the Safe 4337 module is deployed, what networks, and what is the address. So now let's do a quick demo sponsoring a user operation with Safe and Pimlico using the permissionless JS library. So there are some steps we need to do. If you are familiar with Pimlico, can you raise your hand? Okay, cool. First of all, we need an API key that will allow us to interact with Pimlico API, to interact with the different actors of the ERC 4337, like the paymasters, the bundlers, etc. And we need a private key because we need a signer to deploy a smart account, a Safe in this case. Once we have these two things, the permissionless JS library allows us to create different clients, like a public client. We are using the Gnosis chain as an example, but others can be used. So the public client will allow us to query that network, then the bundler client using the API provided by Pimlico and our API key. We can call the API methods related with bundlers, and the same with the paymasters. Once we have all these clients initialized, we can now create a signer or whatever you want to do this, but this is the simplest way. The permissionless JS library is providing a function, private key to account, that will generate a signer, but again, you can use your preferred way. And now here is the interesting thing. There is one function, the signer to save a smart account, that will counterfactually give us, or it will return a counterfactual save. This means that it's a save object that is not deployed yet, but we already know the address. And to do that, we can pass different parameters. Some of them are optional, some of them are not. It's important that we use the version of the save, the 1.4.1, which is the one supporting the CRC. And regarding the address and the salt nonce is a random number we can use to generate different addresses of our save or future save. And the address, we can skip it in case we already, we can skip it if we don't have a save and we want to deploy it, or we can use it if we already have a save and want to initialize it. So once we have the save account object, we can create a save account client. And this will work using VM like a wallet client, but with our smart account now. And this is returned by the create smart account client, where we are passing some properties, the ones you see. After that, we can get the gas prices using the bundler client and the method get user operation gas price. And the last thing, if we want to execute it, we can use the save account client we initialized before, call the method send transaction, and here we can define our transaction. If we want to send some 0.00 something native token to a specific address, we can specify some properties related with the gas, and we will get the transaction hash. If we didn't have a save deployed, it will deploy the save with the 4337 module set up and execute the transaction we are triggering. If we already had a save deployed, it will just execute this user operation. The cool thing with this is that because we are using the Pimlico infrastructure, we can use their dashboard to put some funds there and pay for the transaction fees in all this process, and we don't need to worry about that. So here we have, like the code you just saw. I have commented the address because I don't have a save, and I'm using a random salt nonce when defining our save. So I can just run this, and I just have a signer and some keys, access to a network via the Pimlico API. Here it calculates the save address, which is not deployed yet, and at the very end, it executes the transactions that I defined previously. So that is for the demo. And now we have a surprise for you during the hackathon. I hope you liked that we are offering to you sponsored user operations. So yes, if you are planning to hack with any of these chains like Gnosis, Arbitrum, Base, Celo, Optimism, or Polygon, we are providing some codes you can use in your implementation of the permissionless library. Sorry, you can scan this QR code. This will send you to our hackathon success guide with this announcement, and you can get this sponsorship policies. It's not working. Okay. And for the hackathon bounties, we have two of them. We have $10,000. The best one, which has allocated 8K, is for the 4 best applications that integrate the SAFE 4337 module. And there are some requirements, for example, deploying or connecting existing SAFE accounts, executing SAFE transactions, and supporting SAFE version 1.4.1, and use the SAFE 4337 module. Those would be the requirements for the first bounty. And the second one would be for the best SAFE Farcaster frame. Some requirements like deploying or connecting existing SAFE accounts, executing SAFE transactions, and the frame should be shared on Farcaster and available for us to check. Nice to have if you also want to integrate the SAFE 4337 module in the Farcaster frame. That would be great. So we are on Twitter at SAFE. We have some docs at docs.safe.global. We have updated them with more information about the 4337 if you want to check them. Discord, forum. So thank you very much for attending.
Right, good afternoon, everyone. We all ready? Yeah, good. Okay. Good afternoon, everyone. My name's Matt Hamilton. I'm a developer advocate with Protocol Labs. You probably know us from things like IPFS and hopefully Filecoin, which is what we're going to be talking about a bit here.
But also what we're going to be talking about, or what I'm going to be talking about specifically in this talk, is about interplanetary consensus. Interplanetary consensus is a project that we've been working on for a while with regards to scaling Filecoin and potentially other networks as well. So it fits in the sort of the layer 2, layer 3, layer 4 type space. I'm going to talk a little bit about the background about it, and also a little bit about what it can do, how you can get involved in it, and possibly some ideas as well for your hackathons, and talk a bit about the bounties and maybe some questions depending on time. So like I said, Protocol Labs, you probably know us for things like IPFS. IPFS is 10 years old this year. We've been around for quite a while doing Protocol Labs stuff. IPFS is a decentralized storage network. You probably have used it, especially if you've done anything with NFTs. NFTs use IPFS a lot. And one of the key things with IPFS is it uses content-based addressing. You may have seen these addresses that start QM or BAY and a series of what looks like potentially random digits. Those addresses are actually derived from a hash of the data. So the idea is that if you fetch some data, you can actually verify that the data you get back is actually the data you requested. And also it decouples the location of the data from the actual data itself. So if you think about URLs, when you go along, you go to www.whatever.com/some folder name /report.pdf. That is telling you the location of the data, but obviously that could move. It might be in multiple places. And the whole idea behind the interplanetary file system, IPFS, was that data could be stored in multiple places because you might actually want to fetch it from somewhere that is nearby. That especially becomes important when we start thinking about what does the internet look like when you start scaling beyond our planet. Now that might seem a bit of a lofty goal, but actually it informs a lot of the design thinking behind IPFS. And you'll see that reoccurring when I start talking about IPC, the Interplanetary Consensus. So we had IPFS. One of the issues, IPFS was great, but one of the issues was there was no inbuilt mechanism to actually incentivize anybody to store data. So typically, if you've used IPFS, you may have used a pinning service, someone like Pinata or Infura, in which you pay them to ensure that your data stays on the network. Now, your data may be replicated by many hosts around the network, but at the same time, they could all choose to effectively garbage collect and no longer store that data. It kind of acts a bit like a caching system. But you need at least one node that actually has that data pinned, and that means they're always going to serve it up. And that becomes a bit centralized with the way that works. Now, IPFS has been around, IPFS has no sort of blockchain concept at all and has nothing to do with blockchain or cryptocurrency. The next iteration was Filecoin. So Filecoin is taking some of the concepts of IPFS and uses a lot of the same underlying technology, but to build a storage network in which you have a crypto-economic model behind it. So there's a Filecoin token, there's a Filecoin blockchain, and although the data is not stored on Filecoin, on the blockchain, the data is stored off-chain, the blockchain itself stores the proof that the data has been stored and the economic side of things. So who's paid what, how much, for how long, and all that kind of thing. And then on top of Filecoin, we have the FVM, the Filecoin Virtual Machine, which we launched a year ago yesterday. Yesterday was the first birthday of FVM. As far as I'm aware, we're the first and only layer 1 blockchain to retroactively add an EVM layer and a VM layer on top. So that was about a year ago. But the Filecoin network is huge. You're talking between 10 or I think we say 16 there, exabytes of data storage capacity worldwide. Put that in context, that's about 1% of the entire data center storage capacity on the planet. So that's it's pretty massive. We're also known for libp2p. libp2p is a protocol that underpins a lot of other blockchains. So I think Polkadot, Solana, I think Ethereum 2 all use it. It's actually written there, Ethereum 2, Polkadot, InChain, Golem. They all use libp2p as a mechanism for actually communicating between nodes. So kind of taking all these technologies together, we then, I guess sort of mentioned this, IPFS, a sort of migration IPFS. libp2p with all of those networks is currently securing about $300 billion worth of value on those networks. So it's quite a significant thing. And then, like I say, Filecoin there on the end. But ultimately, like I said, if you start looking sort of beyond our planet, and this may seem, like I say, a bit of a lofty goal, but it informs a lot of the design thinking around IPFS and now IPC, you can't get away from the fact that the laws of physics mean it takes a certain amount of time to transmit a signal a certain distance, right? The speed of light. So getting data from here to the moon is going to take a few seconds each way. Going somewhere like Mars, you're talking, tens of minutes potentially each way, right? So how do we build a blockchain that could actually scale to those potential sizes there? So IPC, Interplanetary Consensus, is our way of trying to solve that. And the idea is to try and scale it to a level where we start to approach the speeds of Web 2 and possibly exceed Web 2. So Web 2 at the moment still has the speed advantage over a lot of stuff within Web 3, mainly because we're dealing with consensus mechanisms in Web 3, right? We have blockchains, we have consensus. We need to get a number of people to agree, to validate, to ensure the integrity of the system. But that has performance implications. The idea behind IPC is we can actually break a network up and have multiple subnetworks, each of which has their own consensus mechanism. So again, if we go back to the idea of being on another planet, the consensus mechanism of the blockchain on Mars doesn't have to be in direct consensus with the blockchain on Earth. They could be separate subnets and then linked through a common parent. So as I say, sort of problems with blockchains, scaling to meet demand, that's the sort of problems we've got at the moment, scaling to Web 2 sizes. Bad composability. So if you use one blockchain, you've got to swallow it all in one go, right? You've got to use kind of how that blockchain is designed and how it is designed to do things. With interplanetary consensus, you have more flexibility. If you want to change out the consensus mechanism, change out the virtual machine, you can do so. It allows you to build kind of things as you want to build them. So we had, this has come out of a R&D lab we had at Protocol Labs. So we had a consensus lab within Protocol Labs. And then, like I said, last year, FEM R&D started in 2021. Last year, we actually launched it. We started productionizing IPC, Interplanetary Consensus. So to give you kind of a bit more of a feel for it, like I said, we talk about scalability in terms of subnets, in terms of creating this hierarchy of networks. Each child can have its own children, so you can create a layer 2, layer 3, layer 4 of them, and so you can create vertical scalability but also horizontal scalability as well. You can have subnets that are region constrained, so you might have a subnet within the EU, within North America, within Asia, for example. Again, to try and work on the basis of it still takes time to transmit signals, right? And if you start to scale these things up and need to be going faster, then you may need, for example, a subnet that specifically is running within one specific geographic region just to deal with the laws of physics and the time which it takes you to transmit signals. An interesting point that somebody brought up earlier on at the Filecoin booth, can't remember who it was, they may be in the room, was about that certain geographic regions may have certain legal implications around blockchains and what you can and cannot do. So you might not be able to have proof of work in one region or proof of stake in one region, for example. So you may have to actually alter your consensus mechanism dependent upon the region. And IPC allows you to do that because you can create subnets within different regions that all then connect up to, like I said, a common parent there. So within IPC, you can use IPC to scale a particular application out to multiple regions or create application-specific subnets, app chains, right? So you might have a particular application that you want to run. So some of the, as an example, at ETH Oxford the other day, last week, some people created a sort of decentralized Discord type service that in which a group of friends can have a group chat going on between them, and they can each run a node, and they create effectively a private blockchain that just exists for the communication between themselves, right? That could then, like I said, that could be anchored to a parent level blockchain, and through that could then access other blockchains and other group chats that are running this system. There is a network called Fluence that is launching, I believe, later this month. Fluence is a decentralized compute network, and they have used IPC as the basis for what they are building because they want to actually do certain specific things that they can't do on the main network. So IPC allows you to create custom actors, custom like built-in smart contracts that could be written in Rust and directly compiled to WASM, and also custom custom syscalls that can access outside of the EVM or the VM sort of sandbox you're within. So if you want to access external hardware or external libraries, external services, maybe you want to actually access something like some AI libraries or something like that, then you can do that with that. And you might have specific ones that are tailored for certain things, like hard privacy. You might want to have a subnet that's dedicated to fully homomorphic encryption, something that is currently at the moment a very intensive process you wouldn't necessarily want on a general purpose subnet, but you might want to have your own separate subnet that can do FHE, for example. So like I said, it's effectively infinitely scalable because you can actually build subnets off of subnets off of subnets. And also the idea is sort of going forward, at the moment we've restricted it, just to be aware, we've restricted it just to layer 2 off of a layer 1 for now, just while we're working on things. In theory, you can go layer 3. We've just disabled that at the moment, just while we're just ensuring that everything works there. A lot of this is still very much in development, although, like I said, we have got a production project that is going to be using this and going live, I think, later this month, Fluence. So, yeah. And like I say, it's customizable. So you create your own subnet. You can choose things like your own gas schedules, your own native tokens, membership rules. Might be a public network, might be a private network. Your own block time. And you can also, like I said, customize things like create your own, you could put your own runtime on there, right? So say you wanted to port over the Solana runtime and run it on there, or the Move runtime, you could do that as well, right? Or create custom syscalls that can access outside information. So just kind of giving you a sort of diagrammatic view of what this could look like. So you could have layer 1 mainnet and IPC at the moment. We anchor to Filecoin. But in theory, you could anchor to any EVM network at the moment because it is based upon Solidity contracts deployed to the parent. Or potentially even Bitcoin. We're actually investigating at the moment IPC being a layer 2 for Bitcoin networks. And then, like I said, you could have subnets that might be specific to a particular application or genre of application. You could create a gaming subnet or a subnet for a particular game, or subnets for particular regions as well. And one of the things we're working on as well is the idea of kind of ephemeral subnets as well. So imagine you created a game, you have a subnet that is only necessary for the duration of that game, just between the players of that game, just to ensure that, you know, nobody is cheating and the rules are all being followed. But then once the game is finished, you don't need that entire subnet. So that subnet could then just be torn down. So it could just be run for just the duration of that game, or duration of a compute job, or some sort of task, and then effectively roll up the end result and the output, and maybe any proofs that you might need to, you know, validate the process up to the higher level chain. I think I've probably covered most of this already, talking about what a subnet can host. So like I say, different things, different applications, different geographic regions. Yeah, so deploying a subnet is kind of like sort of a start of a journey, and then it could expand onto a whole topology of its own. So it depends whether you're running it. You could have a whole ecosystem running it as well. You could determine the incentives for what people might get for running a node. Ephemeral lifetimes. This is what I was talking about just earlier. You might have things like, games, compute sessions that just need to run for a short period of time, and then the subnet can be, destroyed at the end of that. So this is something that we are working on. This is not, the ephemeral subnet is not available sort of particularly at the moment. I mean, you can simulate it. You can fire up your own subnet, do what you want, and then shut it down. Effectively, that's what you'll be doing for this hackathon. You'll be starting up your own subnet locally on your laptop, and at the end of the hackathon, it will disappear. So in terms of bounties, we have 2 bounties from Filecoin. So the first one is sort of a general bounty around Filecoin. So that's not particularly what I've been talking about in this talk, but is about just general tooling and products that involve onboarding data onto the Filecoin network, or working with the Filecoin economy as well. So anything to do with lending and borrowing on the Filecoin network, utilizing the storage primitives of the network as collateral, for example. So you can actually create storage pools and lend and borrow collateralized by, lending pools collateralized by storage, for example. And then what is most relevant to this talk is we got a bounty for most meaningful use of interplanetary consensus for scalability. So if you were to spin up a consensus subnet here and deploy stuff to it, then that'd be eligible for that bounty. One thing to be very clear is, like I said, we're very known for IPFS. Just using IPFS on its own is not qualifying for the bounties, right? We've had a number of bounties in the past at various hackathons where people have just used IPFS, and that is not sufficient to qualify for the bounties. So you need to use Filecoin either via one of the third-party aggregators, or generally you would use one of the third-party aggregators, projects like Lighthouse.storage, Web3 storage, NFT storage. There's a new project that's just come out called Textile Basin. That's a data lake by the people behind Tableland, which is a SQL database on top of Filecoin. So yeah, those are all potential options there as well. And a couple of QR codes that take you to link to some cheat sheets for the hackathon that give you some more information and some stuff about our tech as well. We've got a Filecoin booth. If you've not seen it, if you walk out of here, we're just sort of straight ahead and slightly to the left at the back there. And by all means, come up and chat to us. I'm also hanging out on the Discord channel, the ETHGlobal Discord channel under the Filecoin ETHGlobal Discord server on the Filecoin channel. So come along there if you have any questions, or come and find us in person. And I think I've got about 5-10 minutes left. If people have any questions about IPC or about Filecoin in general, then feel free to ask them here. Or like I say, you can come and grab me afterwards. Yeah?
Yes, I had a question regarding, do you have some examples of projects that already use subnets, some dApps or some projects already on mainnet?
Okay, so the question is, do we have some examples of projects that are already building on IPC that are on mainnet? Just to be clear, IPC is not deployed to mainnet yet. It's deployed to our testnet called Calibration. So it's not yet on. I mean, in theory, you could deploy it to mainnet, because at the end of the day, its anchor is basically a series of Solidity smart contracts. So you could deploy it to Filecoin mainnet. Obviously, you'd be paying gas for real world gas for doing that rather than testnet gas. In terms of examples, we've got a couple of examples in the GitHub repo, and I will put some links directly in the Filecoin channel on the Discord. So we've got one example of using general message passing, GMP. We've got a general message passing protocol to communicate between a subnet and a parent, and there's an ERC20 token example, what's called linked ERC20 token, and that's showing how you could have, say, an ERC20 token on the parent network, then be transferred to a account on the subnet by having it basically the parent effectively escrow that token, and then the child effectively mint a replica of that token on the subnet, and then when the token's sent back, it's burnt, and then it's released at the top end. So effectively an internal bridge using GMP. So we've got that. I think we have another more complex example that is using what Fluence is using, that is in conjunction with Axelir and doing a bridge from another network right the way in, which is quite an example. But come and have a chat. Like I said, we had some people building at ETH Oxford last week, and I think they're about here, and so I can sort of chat about what they were doing, the sort of Discord type chat thing as well. But ultimately, you can use IPC. It gives you just to be clear here, it gives you an Ethereum endpoint, RPC endpoint that you can deploy to. So you can deploy using any your usual Solidity, Remix, Hard Hat type tools directly to a subnet. So we have a in our docs. So on that one, the QR code will take you to a link. One of them is our docs, but it's docs.ipc.space. And in there we have a quick start deploying a subnet. And that will take you through the steps of deploying a subnet. It will compile a bunch of Rust stuff locally on your machine. Depending upon your machine, that may take a while, so be aware. That can take, say, depending on your machine, it might be a quarter of an hour, it might be an hour to compile stuff on there. So that allows you to basically compile it, initialize your config, ensure that it's pointing at the right place on the parent network, and that the what's called the gateway and the registry addresses are correct, and then setting up some wallets on there, and then creating the subnet that registers your subnet with the parent network, joins your nodes to the subnet, and then you can deploy a child validator here. Now, this example, you'll see the commands repeated 4 times. That's for setting up 4 nodes on the network. Actually, if you're going through this, you just need to deploy 1. I mean, it'll be a consensus of 1, which is a bit artificial, but for the purposes of the hackathon, save yourself a bit of time, and you can run just a single node. And ultimately, when it's successful, you'll get this message here, and you'll see the ETH API show up there, right? So you can then configure that in MetaMask or Hard Hat or Forge or whatever you're using, and access it. We'll get a chain ID there as well, and away you go. Great. Yes.
All of the repos, if I want to go and deploy the contract, where can I find the contracts?
So the question is, where can you find the contracts? So the contracts that are actually deployed as IPC is the IPC itself is actually using. So those will be within the what's called consensus shipyard. There's an organization called Consensus Shipyard. This may be linked in the quick start docs there. If not, there we go. It's now in the Filecoin Discord channel. So in there, the contracts should be within there. Yeah, so it should be within there. Now, I think some of the contracts are, there we go, IPC Solidity actors. So there's information there. And if you need any information specifically about what they do, I can give you some more information about that. But in short, there's 2 contracts. One is called the gateway actor, and one is the subnet actor. And for each parent, there's 1 gateway actor that acts as basically a registry for all the subnets. And for each subnet, there's 1 subnet actor. And that gateway actor is also used as a sort of a post box for the GMP, the General Message Passing Protocol, to communicate between subnets. Okay. Cool. Any other questions? Brilliant. Well, thank you very much. And like I said, you can come find me at the booth, sort of towards the back wall, slightly to the left, or you'll find me on the ETHGlobal channel on Discord. Great. Thanks.
All right. Hello. Good afternoon, everyone. Thank you for being here today. We are going to talk about Arbitrum stylus. Okay, we're going to talk like what it is and a bit how interactions between Solidity and Rust contracts work. So let's start it. Well, first of all, I'm Jose Franco. I'm an integration engineer at Off-Chain Labs, and these are my Twitter and Telegram handlers. I don't post a lot of things on Twitter, and Off-Chain Labs they are the initial builders of Arbitrum 1 and Arbitrum Nova chains, and the developers of Stylus and Orbit. If you don't know what any of this means, please go to our booth, and we will be happy to answer all the questions that you have and talk about this. Okay. So today we're going to split the presentation in the workshop in two parts. The first one is just an introduction to Stylus, what it is, and we're going to see a very simple contract, a counter contract. And then we're going to go one level deeper, and we're going to talk about interactions between contracts that are written in Rust and contracts that are written in Solidity. We're going to talk about reentrancy as well and see an example project. So what is Stylus? Stylus is an upgrade to the the current development environment for smart contracts on EVM chains. So basically now if we want to write smart contracts, you usually do that in Solidity or in Viper. And with Stylus, you will be able you are able to write smart contracts in Rust, C, C++, and other languages, okay? The way this works is that alongside the EVM, there is a new virtual machine that executes programs written in WASM. So actually any language that can compile down to WASM can run on this virtual machine, and both virtual machines can speak to each other. So that means that contracts for Stylus can call contracts in Solidity and the other way around. These are some numbers of developers in these three languages that we were just mentioning, just to compare among them, and also to see that Stylus actually enables new developers to be able to access the blockchain ecosystem, the smart contract development ecosystem, right? Stylus also increases the speed and reduces cost, basically because generally a program written in WASM is going to be more efficient than the one written in Solidity. And also memory usage is improved. And yeah, that means that we can see new examples of advanced cryptography, generative art, on-chain generative art actually, and any other use cases, okay? So right now we have an SDK for Rust, C, and C++. If you are going to build something on Stylus during this weekend, if you want to do it on Rust, there is a great SDK for doing that. But basically any language that can be compiled to WASM can use a Stylus. And actually we have examples of programs written in C and assembly script as well, without the use of any SDK, just in raw WASM code. And well, this is a bit to show the roadmap of Stylus. Now we have an alpha version with a testnet. We are having audits for the code. Once we make sure everything is safe, we will enable Stylus on Arbitrum testnets and Orbit chains. And finally, we will submit a proposal to activate Stylus in the Arbitrum mainnet chains. So how to start with the Stylus? If you haven't done anything, I always recommend these three resources. Don't worry about the links, because at the end of the presentation, I'm going to show you a QR code that goes to our repo that has all the reference links that I'm going to show here, okay? So there is a quick start. It's a page in the docs. It helps you set up your development environment to start writing smart contracts in Rust and deploy them to the Stylus testnet. Stylus by example has more information about small things, small details that when you write smart contracts in Rust, you have to take into account. Like, for example, how you emit a log in a smart contract, right? Stuff like that. And Awesome Stylus is a repository of projects that have been built, Rust and other languages as well, for Stylus. Okay, so you can see many more examples of things that you can do there. All right, so let's see the first example of a contract. This is this is going to be a very basic contract that just has a counter and allows you to increment it. So with this, we are going to see how the code looks like. So let me go here. Yeah. Can you see the screen well? Can you see the code? Yeah? Okay. So this is a basic example. If you have developed with Rust, well, this might be a bit familiar to you. So here, I just wanted to show you a bit what a contract written in Rust look like. Okay. So this contract is called a counter, and actually, we just declare here the variables that we are going to use. We are going to store in the contract. We just have one variable. It's the count variable. It's a U256. And then we have the functions that we can call on that smart contract down here. The way we divide this is by the use of macros. So we can see here the solidity storage macro that tells stylus that we are going to define the struct that is going to tell the contract what variables we are going to store in the contract, right? The entry point tells stylus where the execution of the program begins. And finally, the external macro tells the stylus what are the functions that you are going to be able to call from outside the contract. Okay? If you want to place some internal function or something like that, you can place it before the external macro, and it is not going to be exposed to the public. So this contract has three simple methods, sorry, a getter to get the current count, a set count if we want to change that, and an increment, okay? And yeah, I'm going to show you how to deploy it. Actually, this repo is also part of the resources, and you have all these scripts to perform these individual actions like deploy, get count, increment, and we are going to use it now to test it. So, sorry, I'm going to use this console, which is, I think is bigger here. All right. So for example, if we want to deploy this specific contract, we're just going to call deploy. And what this does is that it's going to send the transaction to the testnet, in this case, to deploy the contract and also activate it, okay? Normally, you will see two transactions here, but because I've already deployed the same code before, I don't need to activate it. It's how stylus works. You need two transactions, deployment and activation. If you activate it once, you don't need to activate it again. The same code. If I change anything in the contract, I need to activate it, okay? And just to show you what it does, actually, if I do this, what it calls is just, it uses the cargo stylus command. If you don't know what this is, don't worry, the Quickstar explains what it is. It's just a util that is a tool that we use to deploy contracts, to estimate gas, to check if the WASM code that we have is compatible with stylus. And yeah, it's just a tool for deploying and checking your contract. So once we have the contract deployed, we're just going to call, we're going to call a couple of functions, and let me show you what these functions look like. So we saw the deploy. We're going to call get count. And for this, we're going to use cast call. And as you see, we're going to call this as if it was solidity. We're just going to call the get method that we saw before. And then in the increment script, we are just going to call the increment method with cast send, because we are changing the storage value, and then another get to get the new counter. So let me show you this. So we do contract address because we need to pass the contract address and call get count. Counter is 0 because we just deployed the contract. So we do increment now. Just sending the transaction to the testnet now. And there we go, and the new counter is 1, okay? All right, so this is the first basic contract. Let's go back to the presentation. Again, if you go to the repository of this specific project, it also has all these that we just saw, all this, the script, it explains what it does and all that, okay? So yeah, I say this because I'm maybe talking too fast, so you can do that at your own pace later. Now, second part of the workshop, how to interact with other contracts. As we saw, we were interacting with the Rust contract that we just deployed as it was Solidity. And this happens because these stylus calls are what I mentioned there, Solidity ABI equivalent, meaning that you just need to know the signature of the function that you're going to call, and that's it. You don't need any implementation details or anything. And the way you interact with other contracts is actually the same as in Solidity. In Solidity, you will import the interface at the top of the contract or whatever you want, and then inside the method where you want to make the call, you just use that imported interface to make the call, right? So in this case, if you are writing the Rust contract, it's actually the same. You import the interface with this instruction, sol interface, and then you configure and make the call with call. We're going to see an example now. So this is an example of a Rust program that is declaring a Solidity interface. And notice that we are declaring the interface as we do in Solidity. We are actually using the same syntax as Solidity. Balance of is written in camel case, and actually this is a signature that you use in Solidity, right? And when you call that contract, that method, what you do is that you create the variable of the interface that you just imported. You create the call. This call new, what it gives you is a configuration to make the call, and then you just call the balance of function. You send the configuration that you just crafted and the parameters of the call that that balance of is expecting. In this case, just an account. Notice also that even though we used camel case to declare the interface, we are now using snake case here, the Rust syntax, okay? More things. When we are creating the configuration for the call, we can also we can change the values, some of the parameters of the call, like the gas used or the value that you want to send, and yeah, all these parameters. All right, so let's talk a bit reentrancy, because in the stylus works a bit different. Reentrancy, as you know, is like one contract is calling another contract, and that contract is calling the same first contract again. So we say that that first contract is being re-entered, all right? So in stylus contracts, by default, this is not allowed. This call will revert, meaning that if you have a Rust program that calls another Rust program, and that one calls the first, the call is going to revert, okay? But this can be enabled by using the reentrant feature flag. And well, if enabled, this will happen. The stylus will flash the storage cache, and it will persist the values that might be used by inner calls. And actually, you do those inner calls by using the new in method instead of the new one, right? And something cool about stylus is that you can actually apply different logics in the same function, depending on whether or not a call is reentrant. So you can have the same method and say, okay, I want this piece of logic for the first time that I'm calling this contract, and then this second one for when it is re-entering the contract, sorry. And you can know if a call is re-entered or not by using this MSG reentrant variable, sorry. Well, yeah, we have some more references here. Okay, so let's now take a look at an example project. This project is going to have 3 contracts. It has an ERC721 contract written in Rust, an ART contract written in Rust, and an ERC20 contract written in Solidity. And we are going to see the following interactions. So the ERC71 is going to initialize both the ART and the ERC20 contract. In this specific case, when calling the token URI contract of the token URI method of the NFT contract, the image is going to be generated by the ART contract. So it's going to make a call to the ART contract. And when minting an NFT, we are going to check the balance that the minter has in the ERC20 contract. Okay, so the minter will need to have a minimum balance of that token to be able to mint. Okay, the code is here, so let's take a look at it. Yeah, here. All right, if, I mean, this code is much more complex than the previous one, so don't worry, you can take a look later at it. But I'm just going to explain the important things that we just saw, okay? So in this repo, we have these three folders, this art folder, ERC20 folder, and NFT folder, which contains the three contracts we just mentioned, right? The NFT contract is an stylus project. It has the main file, which is the live.rs file. And here, and it also has the ERC721 implementation that we are using as a base for our NFT. This code is based on another code that my colleague Rachel wrote in one workshop last year. So if you've seen, it might look familiar to you if you've seen that workshop. So this contract, what it does is that it has the following storage variables, following struct. So we are storing here the art contract address and the ERC token contract address because we will need those to make the external calls, and then all the variables that are exposed are stored in the ERC721 implementation, right? And well, the functions that this NFT has is, well, the basic functions of an NFT: mint, safe mint, burn, token URIs, all that. Okay. Now the art contract is also a stylus project. Okay, and this one is a bit simpler. It only stores the token contract address because we will need it for one thing that we're going to see later, and then it has the generate art function, which is going to generate the art based on a token ID and the owner. Okay, it's going to generate the same image, but the colors are going to change based on the token ID and the owner of that NFT, and the initialize and the getter of the storage variable. Now, notice here that we have a function called generate art and a function called generate art with owner. But we are using the same macro on top of those functions, which is generate art. Here we are telling stylus that for both method, we want like, if we are calling this contract, if we are calling the method generate art of this contract, either of these two functions are going to be called. And stylus is going to determine which one based on the arguments that we pass. If we pass only a token ID, this method is going to be called. And if we pass a token ID and an owner, this method is going to be called, okay? We don't necessarily need to do it this way, but I'm going to show you why I did it this way later. Okay, and finally, the ERC20 Solidity contract is just a basic ERC20 contract based on the Open Zeppelin implementation, and just has the mint function. And I've added here a mint NFT function to be able to mint the NFT from here. Okay, so I want to show you how we've implemented the interactions between the different contracts here. So if we go up to the interfaces that we are importing, we can see another example. So we are importing here both interfaces, one for the art contract and one for the ERC20. And we are importing the methods that we are going to use. Generate art, notice that we are using the method that takes two arguments, token ID and owner. So we are going to call the second method of the two we saw, and the initialize, because we need to pass the different addresses to all the contracts. And for the ERC20, we just need to know the balance of the user who is going to mint. So we just need to import that one, and the set NFT is for the special function that we added. So let's take a look at how token URI method is implemented. Okay, so when we call the token URI method in this contract, as we mentioned before, we are going to generate that image in the art contract, which is another stylus contract, right? Because we are following the implementation, the standard ERC721, so we only pass a token ID. And what we do is that we get the owner of that token ID here, and then we make the call to the art contract here. We just declare the, well, we get the address, we declare the variable, we craft the configuration, we take just the default configuration, and we call generate art. We call generate art, and we pass the token ID and the owner, okay? And what we do in the, when we receive the call in the art contract, we mentioned that we are calling this one because we are passing both parameters. We call the gen art internal method, and we create the PNG, and we just return the base 64 string of that PNG, right? Now, we could also have called these generate art contracts and only pass the token ID and give the responsibility of finding the owner of that token ID in this contract, in the art contract. But the problem is that if we do that, the first thing that we have to do here is to find the owner, is to make a call to the NFT contract to find the owner of that token ID, right? And if we do that, we will be re-entering the first contract. So the alternatives that we have here is we either enable re-entrancy on stylus for this contract, or we do what we did here, which is we create a different method to avoid the re-entrancy call, the re-entrant call, okay? And that's the stylus contract calling the other stylus contract. Now, if we go to the mint function, we have two minting functions. One mint that just mints the token to the user who's making the call, and mint2 who mints the token and sends it to another address. And they both do basically the same. They call this internal method. User has enough ERC20 token balance. And if it has enough balance, it will mint the token. So when we go to this internal method, we see that we are going to make a call to the Solidity contract. And we do it like this. Basically, it's the same as calling the Rust contract. We just take create the ERC20 token contract variable based on the interface we imported. We craft a new configuration, and we just call balance off on that contract, okay? So we are making two external calls, one to a Rust, a stylus contract, and one to a Solidity contract, and we are doing it the same way here. We are treating everything the same way, right? And finally, I wanted to show you also, the call that we are making in the ERC20 contract, because this one is interesting. So we are allowing a user to mint an NFT from the ERC20 contract. And the only thing that we do is that we import the interface of the NFT contract. We just need the mint2 function, and we make the call down here to the mint2 function, right? So remember that when we call the mint2 function here, we will check the balance that the user has in the ERC20 contract. So what's happening here is that the user is making a call to the Solidity contract, who's calling the Rust contract, who's then calling the Solidity contract again. We have a re-entrant call there. But this one is not going to revert, because it started with Solidity and it's re-entering Solidity, okay? I hope you guys are not dizzy with all these calls that we are making here and there. But I hope you get the point. So basically, in the end, we are calling different contracts. We are making calls between different contracts, but we are treating the interfaces the same way. It doesn't matter if it is a stylus contract or a Solidity contract. And I think we have time to run some scripts here. So we have in this folder, in this script folder, we have a set of scripts that just perform individual actions. So we are going to first deploy the contracts. We are going to use cargo stylus deploy for the stylus contracts, and we are going to use forge create for the Solidity contracts. So we are going to run that. and see some examples there. Okay. So let's first deploy the contracts. Okay, and here we have the same case as before because I already deployed this code in the testnet. I don't need to activate it. It's already activated. And we can see that here. Stylus program with the same WASM code is already activated on chain. This deploy script is also going to make a call to the initialize method to just share the different contract addresses with the different contracts, so they know where all the contracts are and they can interact with each other. Okay. And again, while we wait for this, I know I'm talking too fast, but in the end, you are going to be able to get the link to all these resources, and you can follow along later. So we have these 3 contracts here. So let's first try to mint an NFT like that without having any ERC20 tokens. I think it's this way. Okay, so if I go scripts mint NFT, this should revert because I don't have any ERC20 tokens. So let's mint some tokens. Oh, I can't use that one. Let's mint some tokens here. Wait, because I don't remember now how was the variable called. Okay, ERC20 contracts. I can take this one. So let's mint some tokens. All right, so now let's try to mint an NFT. Okay, and just to show you how the image looks like, let's generate the image. I think it was called get token image. Yeah, get token image. Well, you see the image here. You can see exactly how it is. No, I mean, this script also generates an image in the image folder, okay? So we can see here that it has this small smiley in this color. So we are going to transfer that to another account. We have transfer NFT. Okay, and we are going to get the token image again. Well, these scripts actually work like, for example, I've hard-coded everything. When I transfer a token, I'm always transferring the token ID serial to the same address. And yeah, the same for generating the image. So if we see the new image, now the face is red. That means that it's taking a different owner. And yeah, and I think that's all. There are a bunch of scripts more that you can play with. All of this is explained in the repo, and I'm actually going to show you now the QR code because we are running out of time. And yeah, there you have it. Again, this QR code will point to the repo of the project we just saw with the 3 contracts. In that README. In the README of that project, you are going to see all the resources that we just mentioned. If you have any doubt about this presentation or Stylus in general, you can find us at our booth. You can also ask on Telegram or Discord. And I think that's it. I hope I wasn't like too quick and that you got everything that I wanted to say. Okay. Thank you very much.
I think I'm going to start now. Okay, cool. So this presentation is about the bounties that Nethermind is presenting at the ETHGlobal London Hackathon. For context, I am Swapnil. I work at Nethermind. I'm a researcher and I work in some products as well. To begin, the bounties that Nethermind is offering, we kind of first need to understand what Nethermind is. And Nethermind comes in different forms and different ways, different how you're looking at it. But at the core, it's scaling Ethereum and looking for a more fair, transparent, and open future. So Nethermind works in scaling Ethereum in all forms, in securing Ethereum, in making it faster, in making it better, bringing more people to it, and just opening the channel ways for everyone to accept Ethereum and kind of bring the Ethereum technology to everyone. And in that endeavor, what it means is that we partner with lots of companies that work in the Ethereum ecosystem. For example, we work with the Ethereum Foundation, we work with EigenLayer, we work with Starknet, Flashbots, Lido, WorldCoin, any other company that you can really imagine is accelerating Ethereum values, we work with them. And our bounties are just a representation of our work that we do with these people. And we're promoting use of these technologies and hopefully see some cool, novel ideas from you guys. Right, first little question. I'm always happy to take questions in the call or in the meeting and wherever you are. Come to the hackathon booth, and I'll be there helping answer questions. Cool. So one of the technologies that we really believe in is zero knowledge. Zero knowledge allows one to prove execution of a program to a verifier without the verifier having to re-execute the program. Blockchains are using ZK everywhere now. There's ZK EVMs, ZK co-processors, there's ZK for privacy, and we work with quite a few solutions that use ZK. There's Starks, which is the base ZK system of Starknet. There's a lot of technologies that are looking to do proof aggregation, and we have interest in proof aggregation as well because we believe it accelerates Ethereum. And there's privacy solutions. One could call WorldCoin a privacy solution, and where it bridges your identity from the people who can verify your identity. And we promote everyone to use privacy solutions and just ZK technology for accelerating Ethereum. These are some challenges that we've put out for using ZK technology, but you are free to choose any solution that you like, and there's more resources at the QR code below, which links to a more wider discussion of what you can use ZK tech for. But some easy implementations of ZK that you can do is implement a novel ZK publication. There's always new advances in ZK research, and there's Nova, there's Hypernova, and there's every day some new stuff is coming out. If you have an interest in implementing it, come please talk to us. We have ZK researchers who will help you understand the details of the paper, help you go implement it, and achieve new novel solutions. Then there's proof aggregation, which is in line with Vitalik's vision of singularity, where everything is just making a ZK proof and everything just settles onto Ethereum at one point. But to do that, we need to aggregate proofs from everything. A roll-up, my Excel sheet, my smartwatch, everything needs to aggregate a proof, and everything settles on Ethereum. And we have some ideas on how to implement proof aggregation. If you have interest in that, come talk to us. And there's always educational tooling. ZK can be dark magic, but if no one understands it, then there's going to be lack of social trust in it. So if you have an interest in implementing tooling that makes it easier for other people to understand ZK, we also will be interested in that. Then there is maximal extractable value. And maximal extractable value, or MEV, just is an inherent property of blockchains and more so, I guess, distributed systems. It's this process where you can strategically choose what transactions go in which order, and you can change the properties of the block itself. There's a lot of cool stuff happening in MEV. There's PBS and MEF Boost, which is an idea of separating the process of block building from proposing, which leads to better MEV alignment. There's base precoms, which is supposed to move the role of sequencing rollups onto Ethereum itself, while still having the same properties of like 100 millisecond sequencing. You can still, I believe this is kind of the next wave of directions of the Ethereum aligned rollups. And if you have any ideas, we have people in the team working on base preconfirmations and also on implementation. So please come talk to us. And then there's Suave. That is, I guess, not one word to define Suave, but in general, it is a magic SGX box that lets you define any MEV strategy and execute it trustlessly. We work with Flashbots on this one, so if you're interested in implementing new novel solutions like novel auctions for AMM or lending pools, please come talk to us for that as well. There are some of the bounties that we have up for MEV challenges is like pricing of pre-confirmations and block futures. The question really is how do I calculate something that I don't know yet, and it's kind of looking to the future, pricing it back. If you have an interest in economics or any of those, please come talk to us. You'll see two QR codes here. The one on the right is for developing swaps, which are apps on Suave, and we're collaborating on Flashbots that one. So there are some inspirations from the Flashbots forum that you might be interested in. And yeah, on the left is a more detailed list of what challenges we are putting up for MEV. Then there's data availability. Just yesterday was a big day for data availability. Then Kuhn went in. 484 is live on Ethereum now, and we all are seeing the amazing effects of it, like sub-cent transactions. But there's a long way to go. We all know that. There is validiums and violations, which Vitalik was talking about yesterday, where you store the data all off-chain, but you just prove the computation on-chain. And that also has merits where everything now is settling onto Ethereum, but is scaling like a centralized server. Sort of the best of both worlds, but some properties that are a bit different. There's lots of out-protocol DA solutions, EigenDA, NearDA, but there is no concrete analysis of which one's better or what specific properties they offer. If you have an interest in like setting some numbers up to it, like setting some comparative analysis or an SDK that lets roll up stews between different DA layers at a given time based on which one is cheap, that would be a great solution in my opinion for out-of-protocol DA solutions. Right. And also, these new DA solutions are actually lacking a lot of tooling and dashboards where there's not a lot of transparency, what's in the blob, what's in the commitment. And I think there's a long way to go in like educating users of what blobs really do and what these external DA layers do and how can we make it better for everyone. Then there is user security enhancements, and this is kind of in line with Ethereum's 2.0 vision, where we've been building Ethereum and we've been working really hard on making Ethereum be able to build the platform that we want. We want to have a decentralized internet, and we're getting close to that. And now it's now time to make sure that our security is also lined up with that. So account abstraction and all these other technologies help a lot towards this direction. Then on Starknet, we have Cairo-Lang, which is a safe by default language. You do provable computation, but also the language is organized in a way where you cannot leave unsoundness errors in your program. And there's a lot of tooling to be built around this. I mentioned Cairo-Lang already. There's Pimlico, which is an account abstraction SDK, which we can use to build a lot of safe tooling for users. There's also slashing protection software with staking and restaking on the rise. I think it's an important measure that we take to protecting solo stakers from slashing, because we do not want to we want to make sure that they can participate in this new economy, but we do not want to put the risk of restaking on them. So maybe there's some solutions we can do in that direction, maybe SGX or there's other directions. If you have more interest in this, come please talk to me at the booth. Yes, there is RIP 7614, which is adding stack trace to each execution, which really enhances user security and also the user experience. Imagine going to the blockchain and getting a stack trace back for a reverting transaction. That really changes the paradigm, and we're no longer stuck with the old tag of it's Web3 and it's just not the same experience of developing. We can kind of retain those values even while being decentralized. Then there's also modules in wallets where I can extend my wallet that, hey, only sign if the value is less than $10, because this is my safe account. I share these keys with my friends, but I don't want to just spend more than $10 on this account. Right. Blockchain infrastructure tooling. We've been building all these amazing DA layers and rollups and eigenlayer AVSs, but all of it is in fact running some kind of node in some server somewhere. And if you don't make it easy to run these nodes and manage these roads, we will just have a systemic risk at our hand. So we need to kind of make sure that we make that easier. On this effort, there is eigenlayer AVSs, Obel DVT, Layer 0 DVN, all these new networks which really accelerate Ethereum and really let us push the boundaries of what we can do. But all of them require tooling and orchestration and DevOps. And to make sure that we don't have the systemic risk, we need to make sure that we have stable tooling, stable guides, and really good just infrastructure ready for any solo staker to participate in this economy. So some solutions that we are looking for is some tooling and dashboard, maybe some one-click solutions to deploy a layer 0 DVN network, maybe a one-click tooling to deploy some EigenDA nodes and make sure that they can't be equivocated. Yes. So come talk to us at our booth again, as I mentioned, because we have some good ideas on this. Right. The slides seem to be messed up there. Okay, cool. Well, there's account abstraction, and Starknet is a layer 2 network, which is supposed account abstraction natively. What that means is there are no EA accounts. There is no like a legacy behavior on Starknet. You can only do cool stuff in some sense. You can do multi-calls where the whole pattern of approving some spend on an ERC20 and then spending it can now go, because you can just do that in one transaction and you don't have like multiple infinite approves left on money apps, and which can later be exploited, and which we've seen in the past as well. In fact, there's some suggestions to even remove the approve function from ERC20 on Starknet, because you can just merge that into the transfer. There's Pimlico, which provides an SDK for account abstraction, and there's some really good ideas what we want to do with account abstraction. Maybe we can do something like, hey, I only want to do transactions if I send an email. People know how to use email, and we can now connect the email to their smart contract account. Hey, I only want to spend $10 through my email, and I can now program that, and the users, like my mom, can be safe. In this Welcome ID, right? This is like one of the big protocols in proof of personhood area. And if you ever want to build this kind of reputation systems and, like more social organizing on the blockchain, we kind of need some proof of personhood protocols, and Welcome ID is a great direction in that direction. And there's so many use cases to be built with Welcome ID, like, hey, I want to sign in with my Welcome ID, scan my irises, no one else can sign into my account now. So some of the IDs, right, sorry, that's the wrong order. Yeah, some other bounties that we have in the account abstraction track are visualization of the bundles and solvers. There's a whole network like now doing this intent solving, but we need some light in the stack for us. I want to see which is the solver centralization. Is there only one solver just footing all of us? If so, then there's maybe some game theoretic incentive for them to like at one point do a massive attack on all of us. Infrastructure to make cross-chain control of accounts easier. Right now, in this world, what we have is an account on each rollup or each network, and I have to control them individually through that network. But what if I had one account on Ethereum, which controlled all my accounts on all other networks, and I could just sign once on Ethereum, and it would just do everything everywhere else. So there's a lot of tooling to be built in that direction with account abstraction. Infrastructure to manage cross-chain MEV. With this idea of this chain abstraction and swap coming around doing cross-chain transactions, there is undoubtedly going to be cross-chain MEV, and the users should get protection from that. They should be able to maybe get some MEV back, express how they should be MEV'd, because the space is open and there's no clear solutions here. So please, if you have ideas there, come talk to us. And obviously there's account abstraction modules where we can have novel paymasters. I can now pay in ERC20s, I can pay with new tokens, USDC, or whatever I like. And most importantly, I think that something I'm excited for is recovery mechanisms. Today, if I forget my private key on an EOA, I've lost it. That money is never going to come back. We have some ideas of like social recovery where I can delegate an admin like myself or my different account. But I'm thinking, what if I can just do a forget password and recover my account through an email? That would really accelerate Ethereum adoption, in my opinion. And that's an easy challenge. So if you have any ideas for that, come please talk to us. Metaverse, I mean, there's a whole company devoted to it now. Metaverse is now like the blend of creativity of this space is a bending. We have Apple Vision Pro, which is just really changing the world. We have AI coming along. So there's so much creativity in the space to be explored. And blockchain should really accelerate it. We should not like shy of it. Some solutions that we have in the space is Starknet, which is a layer 2 network, which offers like incredible compute. You can do so much computation. And if we want to build a new future of like metaverse, we should have it on chain. And we need loads of compute for that. So Starknet is the perfect solution for that. We also work with Improbable, which is a gaming company, and they're designing like new immersive worlds. They're designing new tooling to make metaverse easier, to make metaverse adoption like faster. Some ideas that we have is like creating dynamic, evolving environments using AI or like generative AI, where I land into a space and just maybe like based on the number of people there in the space, it changes the space. Maybe it's listening to what you're talking to, and it's just on real time changing the space. Some AR solutions where, I don't know, my presentation should probably be in AR and not in this real world. Enhancing gaming experience through Starknet's capabilities. A good example that I would suggest is randomness. It's really hard to get randomness, but we have some good solutions for randomness on Starknet using VDFs. So I would encourage the use of that in some game generation and map generation. Then there's institutional. And I kind of see this as the old world, and we kind of need to make sure that we bring the old world along and impart our values to the old world. So it's kind of, in some sense, I see Nethermind's goal to bridge the difference between the old world, the TradFi, and the new world, and kind of impart some of our values to the old world and bring them along, and not just build a silo of our own. There's so many technologies that we've built that are so useful for the old world, and I can bridge the gap seamlessly. There's Starknet, again. Institutions need lots of compute. They need it quick, they need it fast, and they need it cheap. With Starknet, you have some amazing computation available to you, maybe some Monte Carlo simulations, some derivatives, some financial assets that you just can't do on Ethereum right now can probably be enabled by Starknet. Again, Pimlico, it enables people to have like a programmable experience of the blockchain. For example, a traditional finance asset manager probably wants some multi-sig on what assets they can use. Maybe they want escalations like, oh, I see too much of this asset being used. Some manager should step in. And we can enable those enforcing those hierarchies through Pimlico. There's MEF share, because again, as I mentioned, MEV is just an emergent property of distributed systems. But there's a big problem with MEV in the institutional world. But maybe we can bridge the gap through the MEV share, where MEV share shares the MEV that was extracted from a user back to the users themselves. Some other solutions that might be interesting for you is like on-chain KYC AML. There's like ZK tech, so you can make it privacy preserving as well. Tokenization standards. How can we bring the old assets on-chain? How can we make them cross-chain? How can we enable like people to trade them with the ZK KYC? Proof of personhood solutions for institutions. How can we make sure that the people who are trading these assets are safe and not like gonna use them for wrong reasons? Maybe some proof of personhood solutions would help us there. And usage of Suave, because now we can give Suave uses SGX or this trusted execution environment, which makes sure that we can have a quick correctness of computation. And institutions love that. Actually, all of us love that. So we can build some solutions of auctions and some fair auctions using this trusted hardware. Cool. Then the popular one, staking and restaking. And I mean, there's so much happening in restaking world, but also there's so many risks that restaking brings. I mean, the partners that we work here in this section are like Eigenlayer and Lido. And I'll focus on some of the solutions that maybe we can look in the staking and restaking world. I mean, there's always the first one, which is new restaking use cases. There's ever-evolving suite of extending Ethereum security to a new network, to a new use case. And I don't think we've actually seen all of them. And I expect that I will see some cool ones at this hackathon. But also dashboards for Eigenlayer, Oval or DVT. What I mean by that is Eigenlayer brings a lot of risks. And we need to make that risk apparent to everyone. So we should probably have some published dashboards showing like an overlap of validators across Eigenlayer AVSs, showing like liquid staking centralization on AVSs. For example, if there is a new liquid staking protocol that is restaked a lot, but there's some systemic risk with the liquid staking protocol. If that's slashed, then the whole system collapses. And one of the ways of catching this on is first seeing this, making sure this is in front of everyone's eyes, and dashboards and tools like that, in my opinion, really help there. And also, there's restaking related EIPs. What we mean by that is restaking by itself brings a lot of risk to Ethereum, and we can minimize that if we change Ethereum to specifically be safer to that. For example, when you get slashed on Eigenlayer through Beacon Chain, as in when your Beacon Chain stake gets slashed on Eigenlayer, Ethereum Beacon Chain is not even aware of the slashing. It just thinks that you're running perfectly fine because your slashing is applied when you withdraw from the Beacon Chain. So maybe if you can inform the Beacon Chain, hey, you were slashed through Eigenlayer, and the Beacon Chain can react, right? It may be like it reduces the rewards, you are proposed a fewer times, and there's some other changes that can be done to the Beacon Chain design to support restaking and staking use cases. So if you're interested in research areas, please come talk to us. We have a whole suite of research team that are loving to accelerate Ethereum in the research space. Then there's AI and blockchain. I mean, it's emerging, like we just can't stop it. So we have to make sure that we align it. So I think there's good time that we do some Ethereum AI alignment and make sure that AI works for us and not against us. Some solutions in this space is Giza Tech. Giza Tech is provable AI models where you run the AI in a ZK Snark or a ZK Stark. In this case, it's a Stark. And you can prove the execution of an AI model. Like for example, right now when I ask OpenAI, hey, what is the solution to this prompt, it just gives me an answer back. But I don't know if OpenAI is actually running GPT-4. They could just be running GPT-3 or GPT-2, or it could just be hard-coded strings, for all I know. But if they run it in a ZK environment, then I could be really sure that they're actually running this code, and I can consume this string or this prompt with confidence. And I really believe that open source LLMs are the future. I mean, open source LLMs kind of just happened out of mistake of like some torrent leak, but they've been accelerating at a pace which is much faster than we had expected. There's Olama, and there's so many other models really specializing in different tasks and really accelerating how the open community can accelerate and participate in the LLM world. So some of the challenges we ask of you to look into is explore how Starknet and ZK proofs can like do integrity of ML models. Maybe can we train models on chain? I mean, there's the amount of compute is slowly getting unlocked. Maybe some small models are possible to do already. Can we use AI to improve blockchain onboarding? Right now, I go to, let's say, MetaMask, and it's really hard to actually navigate it. Can the AI figure out what language I use, localize instructions to how I use blockchain, maybe even redo the entire UI again to fit my way? Innovations use of AI and trading. What I mean by that is like, trading is a lot of patterns and pattern recognition, and AI is really good at doing that. Can we make sure that the AI can do a MEV share or even start doing auctions? Can AI do dynamic auctions based on changing market conditions? And how can DAOs and on-chain contracts specify their risks or like their wishes in AI? Let's say I want my DAO to have a constitution, and I want it to be fast. Right now, DAOs are slow because they have to vote for each proposal. But if the DAO can express their demands and their constitution in an AI model that goes all the time, and maybe with some sub-checks that stop the AI if it goes wrong, I think that would really accelerate the adoption of DAOs, because DAOs right now are kind of slow in action. And lastly, there is the Starknet track. Starknet is a layer 2 scaling solution that uses Stark for zero knowledge and privacy. It enables just a new level of computation in the Ethereum space. You can do Monte Carlo simulations, you can run AI models and whatnot. So some of the solutions that are available in the Starknet ecosystem is Skyrolang, which is their ZK Stark language, enables just unlimited amount of computation. Sharp is a shared prover service. So you can write your program in a nice high-level language and send it to Sharp, and it will give you back a proof for it, which enables just, I forgot to add, cheap proofs for it. And also it verifies them on Ethereum for you, so you can do some off-chain ZK solutions using Sharp just today. And then there's Voyager, which is an API service and a Starknet RPC service for Starknet. It enables you to get seamless data, quick access to Starknet data itself. Some of the ideas that we would like to see is like just pushing the limits of Starknet computation. How can I do some kind of financial derivative that really just pushes the bounds of Starknet computational capacity, using Starknet's native account abstraction protocol for enabling the next generation of users to onboard to Starknet, and also building novel tools using Cairo 0 and Sharp. Cairo 0 is a low-level ZK proof language, so the proofs that you're getting from Cairo 0 are the most efficient ZK proofs that you can get in a nice UI and nice efficient language. So I think that's a goldmine of tooling to be built there. And lastly, you can follow us anywhere. You can come join to our Discord, come talk to us at our booth. We are happy to answer questions. If anyone has questions right now, I'm also happy to chat right now or outside.
Thank you. Hi, thank you for the presentation. Quick question is about Starknet. I'm curious about when you say you can do computation for like Monte Carlo simulation. So my understanding is you should use Cairo, is correct, as a language? Yes. And you write a program which you would...
yes. So the question is, if I said in one of my examples, if Starknet you can do Monte Carlo simulations with Starknet, and the question is, do we have to use Cairo for programming that? And the answer is yes. Cairo 1, which is the new version, is very Rust-like. In fact, actually, I tried programming Cairo 1 with Claude, and it works really well. So you don't even have to do that much. You just have to ask Claude to write the program for you. But you can now program your ZK proofs in a Rust-like language on Starknet.
Where do you, sorry, the last one. Where do you store, I mean, can you use the result? How do you use the result, or
Ah,
do
I
you
see.
store the result, or?
Yeah. So as an example, if you're running the Monte Carlo simulation fully on chain, then you could compute the result and just save it in a storage slot, or you could just like emit it in an event and then read the event off chain. Yeah, but you can also send a Cairo 0 program straight to Sharp, where it gives you back a proof. You can consume the proof and the output. So there's various ways to use the output of a Cairo program. Cool. If that's all the questions, then I'm happy to chat outside. Come see us at the booth, at the Nethermind booth, or on the Discord, and I'm happy to answer questions. Thank you.